Hello, today we're going to talk about design processes related to decision making on larger infrastructure projects. This is some information from a textbook we used to use on the course, which was Chapter 10, Design Fundamentals. First of all, as engineers and technical people, what do? Well, of course, we help identify and solve problems, and they're usually practical problems to help society, particularly with designing and building of infrastructure. We're going to use this example to sort of help us understand how you would design a problem. So in this case, we have a lake with some properties around it. There is a water quality issue to do with high phosphorus levels and green-blue algae growth. And this is a concern. So this is a hypothetical case study of Rock Lake, they're calling it. So how can we solve the problem of the algae in the lake? That's the... so we're going to talk about the design process, starting with the initial problem and how we identify alternatives, and then go through, of course, the alternative selection method. So our design is a process of devising a system component to meet desired needs. And this is so we always have to go through sort of a decision-making process. The start of any project can be iterative, and meaning we start and go back again sometimes. And we use, of course, science and math to do this. So we start off all by identifying the need or being clear. First of all, clarify what the problem is. Then we go and we maybe have to collect some background information, do some research. Following that, we develop some alternative approaches or concepts to solve the problem. And then, of course, we're going to evaluate the different alternatives. We want to learn how or figure out how we can select the best alternative. And then, of course, once we pick the best design, we then can complete the higher level of design and implement the final solution or alternative that we would like to. Reduce the phosphorus input. We can do some sort of a chemical treatment, like adding copper sulfate. We can add some organisms to feed on the algae, or we can just, one option, of course, is always to do nothing, but depends how bad the problem is. So for Rock Lake, these are the options. Replace all the septic systems with new, improved septic systems that maybe have enlarged drain fields, or, as I say, incorporate phosphorus removal. Or we remove on-site systems and put in a sanitary sewage system and build a centralized wastewater treatment plant. Or we put in a sewage system and collect it and send it to a nearby city. So these are three options that, for the purpose of the case study, they've come up with. And we have a little design schematic. So this is sort of like showing the concept graphically, right? So A, B, C, D. So this is existing case. This would be increasing the size of the beds or improving the beds, the septic beds. This would be putting in a local collection sanitary system and bringing it to a local plant. And this would be putting in a collection system and then pumping it 10 miles, for example, to the nearest town where they would receive it and treat it. All right, it's not going to let me stop here. I'm just going to